the square root property. So solving quadratics using the square root property. This is a special case, meaning it doesn't work all the time. It only works in a special circumstance. And that circumstance is if I can write an expression in this form where I've got some number times a square term set equal to another number. And this time it's not equal to 0, although it could be, but most of the time it's equal to a number. But this is a very special case. Only works if all I have is a square term. And the square term could be a group. We'll do examples in a little bit where it's a group. But if I have a square term and then some constants, I can use this method in that. Only in those cases. And so the first thing you do is, well, you isolate the square term. Solve for the x squared. Once you get to the x squared term, then you use the square root property. So this is the square. So remember, this has to do with, it's the absolute value case, right? When I take the square root, it would have been the absolute value, meaning I could have had a positive number in my square or a negative number. And so that's why we do the plus minus, meaning this has two answers. X is either the positive square root of k, or x is the negative square root of k, because when I square them, it would have got rid of the negative version. And so there are two possibilities, and you have to remember that. And so again, we usually put plus minus on it. Alright, so solve the following, use that method. So the first case I have to isolate, so first thing you do is solve for your x squared. So I'm going to move the 5 over, so I get 3x squared equals 12, divide by my 3. So x squared equals 4, and now I use my square root property. When I take the square root, it really would have been absolute value of x equals the square root of 4, so we use that plus or minus square root of 4. And then you write your answer in simplified terms. Don't leave it square root of 4. Always reduce fractions and always reduce square roots. And so this reduces to plus or minus 2, right? The square root of 4 is 2, and so there are two answers. X equals 2 or negative 2. So if I graph that function, alright, my answer would be x. So if I set it equal to 0, it would cross the x-axis at 2 and negative 2. Alright, second example. Isolate the x squared, so I get negative 12, so x squared equals negative 12. But this time, if I try to use my square root, it's the square root of negative 12, which is not real. I only want real roots. And so the answer when I get non-real roots means this function was the no solution case. If you graphed it, it's completely above the x-axis. And so there are no real solutions. And we leave it at that. We don't want imaginary solutions. We only want real solutions. Alright, so whenever you get an imaginary number, you just write no real solution or no solution. Right, next example. Isolate the x squared, which means I divide by that 0.25 out front. And so x squared equals 28. Take the square root, remember, plus or minus square root of 28. And then remember, we always write these in reduced form. And a lot of calculators will do this. But 28 is 4, right, you pull out the perfect square. 4 is times 7 gives you 28. And then the 4 is the square, so I can pull a 2 out of the 4. And so this simplifies to plus or minus 2 square root of 7. So x is 2 root 7 or negative 2 root 7. And just be aware, we always like things in simplified terms. Now, just a kind of an FYI, when I teach calculus, I usually tell students leave it square root of 28 when you plug it in the calculator, because it's actually easier to plug that in than the 2 root 7. But we always reduce answers in this class. So when you type your answers into the computer, always type them in reduced. Reduce your fractions, reduce your square roots. Alright, the next couple of examples are examples of groups of square terms. Remember, I can use the square root property if all I have is a square term set equal to a constant. The square term could just be the group squared. And so that's what we're going to do here. This would be the square term, right? T minus 12 squared. I'm going to isolate that, so I'm going to solve for the square term. So I'm going to add 3 to the other side. And so I get t minus 12 squared equals 25. And then I'm going to use the square root property here. This is where you kind of use this property hand in hand with completing the square. All right, so if you look at the completing the square video, this is kind of where they use it here. Right, using it on this property. Now we're just going to use the square root property and then the other methods. But this is where you could use it. I use my square root property here. It means I undo the square by taking the square root. When I do that, I take the square of the 25. I've got to remember, this would have been absolute value, so it would have been plus minus. So t minus 12 on this side, because I get rid of the square by taking the square root, plus minus the square root of the constant side. So it's the plus minus on the 25, which means I get t minus 12 equals positive or negative 5. And so there are two equations I have to solve. And t minus 12 equals a positive 5, t minus 12 equals a negative 5. This comes from the absolute value principle. This would have been, another way you could have written it would have been t minus 12 absolute value equal 5. When I take the square root and get the absolute value, then you get those two equations you have to solve. T minus 12 equals 5 and t minus 12 equals negative 5. And then you solve, you get two answers. So the first one is going to come out 17, and then the second one is going to come out 7. So you get t equals 17. If you plug 17 in, you'd solve, and if you plug 7 in, you'd solve. Double check and make sure I didn't do anything silly. So t minus 12 equals the square root of 25, which is 5. T minus 12 equals 5. T minus 12 equals negative 5. Alright, I think I'm good. Alright, the last one. Again, this is the same idea. X minus 3 squared equals 2. So it's already set up, I don't have to do any simplifying. But I get rid of the 2 by taking the square root. When I take the square root, I got to remember it's plus or minus. So it's x minus 3 equals plus minus square root of 2. Again, another way to think of that, it would have been the same thing as the absolute value of x minus 3 equals square root of 2. And so there are two solutions. X minus 3 equals the square root of 2. X minus 3 equals the negative square root of 2. And then you solve. So x equals square root of 2 plus 3. That was a plus 3. And leave it exact. A lot of times we want these exact. So it's exactly square root of 2 plus 3. And this one would have been x equals negative square root of 2 plus 3. And it's exactly negative square root of 2 plus 3. And so leave the answer exactly in reduced form. A lot of times the website will ask you to do that, because that's exactly the answer. Square root of 2 is a number, right? It's an irrational number, but it's still a number. And so square root of 2 plus 3 is exactly the number that will solve this. Negative square root of 2 plus 3 is exactly the number that will solve that. Another way to write it would be 3 plus or minus the square root of 2. Right? If you've seen that form, that will solve it as well. Alright, so that's the square root property of solving quadratics. Alright, next one will be the quadratic formula, and that's the next video.